everyone, welcome back from winter break into another week of math counts. So this week we are going to be talking about plane geometry. The title on top has been fixed ever since unit 1 algebra. I haven't changed it, but now it's unit 4 geometry, already unit 4. In this video we're going to be talking about polygons. So there's a good definition for polygons, and then I'm going to show you a bunch of examples just so that you understand the concept better. Polygons are a closed plane figure with only straight edges. So something like this. Well, let's talk about edges first. Edges. One, we have the edges requirement. So something like this. Oh, I should say straight edges to specify. Something like this is a polygon because all of the edges are straight. But something like this is not a polygon because it's a curve. There's a curve here. So this is a polygon and this is not. Second requirement, the shape has to be closed. And so that means that something like this is still a polygon and something like this is not a polygon. And neither is something like this or something like this. They have to be closed in order to be a polygon. And then I think that's about it. Edges, straight, closed polygon, and of course they have to be on a plane. So I don't know if you guys have learned about the XY coordinate, but you should be able to map this out on an XY coordinate. Or something like this. You should be able to draw out your shape like this, perhaps. You also as you go on, you can move on to 3D shapes. And we're going to cover that later, but you cannot put a 3D shape on an XY coordinate. You have to have an XYZ coordinate. And so something like this, a cube, that is not a polygon. And so this is just a general overview about polygons before we go into more specifics, but there's also a special property that all polygons share. And now this is this formula right here. Or well, there's actually two equations, but right. Okay. So sum of the interior angles. Sum of interior angles is this equation right here. N minus 2 times 180. And then the sum of exterior angles is always going to be 360. So I'm going to pull out our triangle. I believe we talked about the triangle in detail previously, so I'm going to try to apply what we know about triangle angles into these rules just to show you that's true for triangles first. So let's say we have a triangle like this. We have angle A, or I'm not quite sure the naming convention for these. That's okay. A, B, C. And then we have our exterior angles. So this exterior angle here would be 180 minus A. And this exterior angle over here would be 180 minus B. And this exterior angle right over here would be 180 minus C. So, I should add here, define my variables first. N is equal to the number of sides that the polygon has. So in our case, for a triangle, or actually I should say edges, number of edges. So for our triangle has 3 sides, 3 edges. So we have 3 minus 2 times 180, which is equal to 180, which fits and according to what we proved previously, that all of the interior angles of a triangle add up to 180. So I've also included the exterior angles in this. So we have 180 minus A, 180 minus B, 180 minus C. So these, the value of these exterior angles are based off of the interior angles. And so we're going to show that when we take the sum of all of these exterior angles, so we have 180 minus A plus 180 minus B plus 180 minus C, and that we're saying here that is equal to 360 degrees. Well, 180 plus 180 plus 180, that's equal to 3 times 1A sambaye, say 540. minus a minus b minus c, which is equal to minus a plus b plus c. And we know that a plus b plus c is equal to 180, so this is just 540 minus 180. And that is equal to 360. Yeah, 360, so say, 360, which is what we said here. Of course, this is just one shape. A triangle is just one type of polygon. These two rules apply to all polygons. So that includes, squares and, rectangles and the like. It includes kites, includes, I've never learned hexagons, octagons. Don't quite remember how you draw octagons, but octagons, heptagons, which means that they have 7 sides. I don't know how to draw a heptagon, unfortunately. I would love to do a proof about this, but for now, for your problem sets, you guys just need to remember these 2 items. And thank you guys for watching. Stay tuned for me to go into more detail about the other types of polygons, and those are, well, I already covered triangles, trapezoids, parallelograms, and kites. Also, possibly more detail about triangles. Thank you guys for watching. See you guys next time.